In this video, we're going to take a look at activity 314, part 4. And within part 4, we're going to see that there are actually 4 subparts, an A, B, C, and D. So I've got the part 3 code up from the last video. I'm going to go ahead and go to File, Save As. And we're going to name this part 4A. I've already got one that I tried before, so I'm just going to overwrite it and replace it. But I can go ahead and in this, when you have one, I'm going to go ahead and put part 4A up here. Task description. We'll go ahead and in part 4, we'll grab the red text for part 4A, which once I paste it, we'll kind of read through what it's going to do. So once you paste it in, it may do this to you. You might have to scroll back over. Usually what I like to do is after each sentence, I like to go ahead and just hit enter or kind of break up the task so that way it brings it over and makes it all on one screen so I don't have to scroll over to the right. So here it says make a motor spin as long as the bump switch is being held down. Its direction depends on whether a person is within 20 centimeters of the ultrasonic sensor. If the button is released, the behavior will repeat if it is pressed again. So here I can go ahead and I'm going to get rid of the program. So keeping my task main curly braces, and we'll get rid of the pseudocode from part 3. And we'll go ahead and start writing. So here it says make a motor spin as long as the bump switch is being held down. So I'm going to go ahead and probably, and it says that the behavior will repeat if it's pressed again. So that means we need to repeat indefinitely and to make up a while 1 = 1 loop. And then we'll say while the bump switch is pressed and if the sonar reads less than 20 centimeters. So we'll say start the motor. And I'm going to use the right motor. Doesn't matter if you use right or left or anything like that. Start the right motor going in reverse. Let's say if somebody's near it, then we want it to go in reverse at half speed. And you can decide how fast you want it to go in what direction. But then we can say else if the sonar reads greater than 20 centimeters, then we want it to start the right motor going forward at half speed. And then one thing we may want to have happen, we'll test out the behavior, we'll see what happens, is we may have to put another line in there here in a moment, but we'll take a look. All right, so I'm going to start writing my pseudocode. So I'm going to go ahead and say while, I'm going to tab over, go while, or if we write it all over at the left side, while 1 = 1, I need a left curly brace to set up my starting of my while loop. I'm going to go ahead and go down. I'm going to do a right brace so that way I know anything in between those two braces is going to be repeated. And then I can go ahead and start to say if the sensor value of the sonar is less than 20, inside of here I'm going to do a right and left brace. So I know that whatever's inside of the if condition, then we want to go ahead and put our command. Start motor, right motor, comma, -63, semicolon at the end because it's a command. And then I can go ahead and put an else, because one thing that I have done with my students is I give kind of a suggestion. I want them to utilize an if-else structure when they write this. So I'm going to go ahead and do an else. The else is going to need, I'm going to hit enter a couple times, and then otherwise I'm going to go ahead and have it do start motor, right motor, comma, 63, and semicolon there. And that should, so right now there gives an if condition, but we did forget about the bump switch being pressed. So underneath the while loop, if I need to go back in and add that in, I can say while sensor value of bump switch is equal to 1. I'm going to need a brace underneath that while loop. and then the one after the else, which is what I was leaving a little bit of room for. And here's where some things get a little bit kind of confusing. So it's like, all right, well, let's go ahead and grab while 1 equals 1. I usually like to leave the task main braces out of the fix formatting, but let's see what we've got once we fix the formatting. It makes it a little bit more clear. So while 1 equals 1, we repeat indefinitely. Here's the start of that brace. Here's the ending one, so we can see vertically where they're located. So here, this is our repeat indefinitely, which we can grab from our pseudocode. So that's pretty easy. And then here is while the bump switch is pressed. So again, just checking my pseudocode to kind of help out. And then if the sonar reads less than 20, so there's our next line. Start the motor going in reverse at half speed. We see that in our command line there. And then else if the sonar reads greater than 20, which is pretty easy to go through and see there. And then we want to start the motor going forward at half speed. And that's pretty much it. So I mean, the rest of it here is end of the while loop for the bump switch equals 1 if you want to throw in some comments. So end of while bump switch is pressed. And then we have end of while loop. Okay, so let's go ahead and see how this program behaves. Let's compile, see if there's any errors. Nope. Let's download, and while we're at it, we will, once our debugger windows come available, we'll change over to sensors and see we've got the sonar reading at 155. So I'm gonna go ahead and hit start. You're gonna see your execution bar. Nothing is running yet until I press the bump switch. So the motor's turning on, I've got the bump switch being pressed, and it's running going forward. If I get close, there's where it goes in reverse. If I take my hand away from it, it goes forward. There's it in reverse. There's it going forward. So it's changing its direction. However, here's one of the issues of what I was kind of noting before. Now, it's only supposed to do it while the button is pressed. So what's happened is it's got caught in a forever loop. So it's caught in one of your loops there. So we need to turn that off. So I'm going to go ahead and stop. And what it is we say while the bump switch is equal to 1, so it's caught inside of this loop. So where it's going to go through and keep doing that. So we need something to help it whenever the bump switch is not pressed. So here's the while 1 equals 1, and outside of the bump switch being pressed, so I'm going to go ahead and hit enter here. We're going to put a command in here to stop the motor, right motor. So whenever while the bump switch is not being pressed, it's just going to stop. So, and that'll get us out. So let's compile, download the robot. Let's hit start. Now if I press the button, it runs, still responds to our sonar. If I release the button now it stops the motor. So now we've got another command in there that it has to check in order for it to go through and do that. So this will go through and fix our issue of a continuously running motor. So now I might want to put this in the comments. If button isn't pressed, stop the motor. We'll say stop the right motor. And this would end up finishing out activity 4A, which is making a motor spin by pressing a bump switch and its direction depending upon how close it is to our sonar.